need to expose your FastAPI endpoints to AI clients without rewriting your entire API. You'll see how FastMCP from FastAPI converts a complete FastAPI app into an MCP server in just 2 lines of code, preserving all your existing routes, models, and logic while making them AI-callable. The pattern is simple. Take your working FastAPI instance, pass it to FastMCP, and instantly get a fully functional MCP server that mirrors your API's capabilities. We'll run it and demonstrate how the conversion maintains endpoint behavior while adding LLM-friendly tool interfaces. Hash assumes the FastAPI app from above is already defined. From FastMCP, import FastMCP. Hash convert to MCP server. MCP equals FastMCP. From FastAPI, app equals app. If name equals main. MCP, run. This demonstrates the adapter pattern for API transformation, specifically converting REST endpoints into AI-callable tools. The technique bridges the gap between traditional web APIs and modern LLM workflows by automatically mapping HTTP operations to MCP components. What makes this distinctive is its ability to preserve existing API contracts while making them consumable by AI agents without manual rewriting. The pattern works by analyzing your FastAPI application's OpenAPI schema and generating corresponding MCP components. Each HTTP endpoint becomes either a tool or resource based on configurable rules, with parameters and return types automatically inferred from your Pydantic models. This declarative approach maintains separation of concerns, letting you focus on business logic while the framework handles the protocol translation layer. This approach matters because it accelerates AI integration without requiring parallel codebases. Instead of maintaining separate REST and MCP implementations, you get AI compatibility as a derived capability from your existing API. The trade-off is that auto-converted APIs may not be as optimized for LLM usage as purpose-built MCP servers, making this pattern ideal for prototyping or gradual migration rather than production-scale AI systems. Let's break it down line by line. Hash assumes the FastAPI app from above is already defined. From FastMCP, import FastMCP. This imports FastMCP, the adapter class that converts FastAPI apps into MCP-compatible servers. It handles protocol translation between HTTP and the model-callable protocol, enabling AI model integration. Hash convert to MCP server. MCP equals FastMCP. From FastAPI, app equals app. This converts your existing FastAPI app into an MCP-compatible server. The From FastAPI class method adapts FastAPI's routing and middleware to FastMCP's protocol, preserving all your endpoints while adding AI-callable tool capabilities. It's the bridge between traditional HTTP and AI tool execution. If name equals main. This is Python's standard entry point guard. It ensures the server only runs when this script is executed directly, not when imported as a module. Prevents accidental server startup during testing or library usage. MCP, run. This launches the FastMCP server, starting the async event loop and exposing all registered tools to AI models. Without this call, the server remains inactive. No tools are discoverable or callable. Standard entry point pattern for MCP-enabled applications. FastMCP FastAPI integration. The FastMCP from FastAPI adapter bridges 2 ecosystems, converting FastAPI routes into MCP tools while preserving existing HTTP endpoints. The if name equals main guard ensures the server only runs when executed directly, not when imported as a module for testing or mounting. This pattern enables gradual migration from REST to MCP without breaking existing clients.
The adapter that disappears becomes the protocol.